that should do. So now it's recording.
Okay.
And then it'll save once it's done, you have to save the file as with some file name, and then you can airdrop it to me.
Okay.
And then I can just upload it to YouTube and stuff for you.
Okay, show me how the mic works in case you need it.
Basically, you have to flip the switch.
Mm-hmm. And then just.
And you can talk.
Okay. And then this one works as well.
You can't use it to advance your slides, but you can use it as a laser pointer. You click that button. Yeah.
Or like I just.
Or I just use my mouse. I actually
yeah.
use my mouse most of the time.
Okay, cool.
Alright, sounds good.
Oh my god.
That's a good time.
So the plan for today is to do PCA and then regex and then everything else.
Sure. Yeah, those are practice questions on PCA would be good. You might not need to do as much conceptual overview because I spent most of Thursday lecture doing another PCA lecture.
Oh really?
Yeah, so it's up to you how you want to use your time, but chances are that
yeah, there are like a lot of questions.
Yeah,
like,
if there are questions.
Yeah, it's like more like question based.
Yeah. I think that'd be good because I didn't do any practice questions.
And then there are like practice questions from the previous midterms.
Yeah, that sounds good.
Yeah.
And then you can pace yourself too. Like if you notice people are just killing it and getting everything right, just skip some questions and move on to other ones.
And then need to message
did it like sign in or anything?
Yeah, I should have. It's showing that I was signing in.
Yeah.
Yeah.
I would like sit in the front or like.
Sit wherever you want, but then. Okay, so this is a plan. Let me show you. We have like the video, and then we'll like talk, both of us. But then we'll have like questions where we'll stop and give them time to work, and then during that time, we'll tell them if you have like questions, like raise your hand, and we'll be around to have them help. And then that's the time where you will be around to help. Yeah. Thanks for coming.
Yeah, no problem.
Yeah, I'll check in like at the end of the lecture or like Ishan. No, actually, you have to do it in the beginning, right?
Yeah.
Okay, the other is AI. Is it you or she? How are you? How do you feel? It's very awkward.
Oh, it is. We are webcasting this.
Yeah, Sam is there.
What day?
Sam is there at the end of the lecture hall.
Okay.
And I put the break and then a tennis one in the middle of like after the PCA finishes. Also, this is the mic if you want to use. It's like you put it on, then you talk, and then you can use the laser with this. But better use the cursor, I think, the mouse.
Yeah, I think this is probably a better idea. Here we go. Wow.
No, you have 2 minutes.
Yeah.
Is this your first time going to lecture?
Yeah, for the whole class, yeah. Yeah. It's a decent turnout as well. Do you have any important announcements?
With the Midterm logistics post on Piazza.
Okay. I guess someone just asked on Piazza if we're having discussion today, so I'll tell them yeah.
Yeah. We have the discussion also. Maybe say that. If you want, I can start this.
Here we go.
Okay. Say that after the reactions about what we will review, the PCA was the big one, and then Regex, and then everything else.
As we let them know? Yeah, sure.
That's why we have the plan.
Yeah.
We have 1 minute to go. What should I do?
This ought to be fun.
Next to then I'll take over after the break.
I would say you should probably like sit in the front or something. Seems like the best idea.
Okay, here we go.
Here we go. Hello, can you guys hear me? This seems to be good to go. Alright, it's 9:40, so we're going to get started. Before we get started the specific plan, just a couple of announcements. So there's a midterm logistics post for the midterm tomorrow, so if you have any questions related to logistics, check that out. Someone asked on Piazza if we're having discussion sections today. Yes, we are. Each DA is going to be hosting their own midterm review, so feel free to attend whichever one you're comfortable with. And with that, let's get started. So during the previous lecture, Sam had put up a survey for you guys to fill out regarding what topics you wanted to see during your midterm review. And BCA was the most common, second most common, and one of the third most common ones. So we figured that's what we should focus on the most. So that's going to take up the bulk of our midterm review. We're also going to focus on regex and EDA, and if we have some time, we're also going to focus on stuff like Pandas and SQL. So let's get started with BCA. I've decided that I'm probably going to start off with a decent bit of theory and then maybe a couple of conceptual questions. And after that, we can start looking at actual practice problems problems from past midterms. So to start off from the very basics, what does BCA stand for and what does it actually mean? So anyone here, what does BCA stand for? This is one of the easier questions in the review, I swear. The answer is on the screen. Yes? Fantastic. PCA stands for Principal Component Analysis. As the name implies, we use PCA when we're trying to figure out what the most important components or features of the data are when we're trying to analyze the data set. Now, the overall goal of PCA is twofold. One thing is we want to maximize variance. So you want as much of the variance in the total data represented in as few of the components as possible. So if you have, let's say, maybe 40 dimensions in your data, you still want a way to capture as much of the variance across all 40 dimensions using just 2 or 3. Additionally, you want to capture your data from high dimensions to low dimensions in such a way that you can still get your original data matrix back. Now, it's fine if you have some loss of data, but if you're doing PCA right and PCA is applicable, then you should be able to decompose high dimensional data. You should be able to project high dimensional data into low dimensional data in such a way that you can get most of the data back, even with just the few principal components that you have. Any questions so far on the theory? Okay, moving on. When should PCA be used? So there are different ways of applying PCA and it's not always suitable. So can anyone tell me one time they think PCA might be a good idea? Yes? That's correct. One time we should use PCA is if we're not sure what exactly the trends in our data are, we're not sure what we might want to predict, and we're not sure what we might want to use specifically to predict that. Other times are if we think the data are of low rank. So even if you have several dimensions, you think there are just a couple of really important dimensions that determine most of your data set. So yeah. Another aim of using PCA is if you have high dimensional data and you want to observe like clusters of them, it's really difficult to do once you hit like 4 dimensions, right? We don't know how to visualize in 4 dimensions. But if you use PCA, you can project that same high dimensional data into just 1, 2, or 3 dimensions, and that's a lot easier to visually understand, and by extension, it's easy to visually identify groups of data when you have only 2 or 3 dimensions. So that's another time we want to use PCA. By show of hands, who here knows what rank means for a matrix or a data set? Okay, so a decent population of the class. So yeah, rank is something that's covered in like a linear algebra prereq of 54 or 16a. And by definition, it is the dimension of the subspace spanned by the columns of a matrix. Now, if you don't know what that means, that's all right. If I were asked to calculate rank or even explain rank, that's definitely not how I do it. So when it comes to rank, how I like to look at it is in terms of the number of columns with which you can describe the entire data set we're working with. Now, that's still not exactly clear. So let's look at an example. So this is a data set of distance and time. Bear in mind we're using the metric system here because you guys don't know how to measure units properly. But despite that, when we're talking about rank, we should be measuring how many columns can be used to express all other columns as a linear combination of them. What does linear combination mean? A linear combination of 2 columns would be A column 1 plus B column 2, where A and B are any scalar, let's say any real number, 0, 1, 2, 3, minus 1, minus 2, minus 3. So you could say one column is a linear combination of 2 other columns. If there were 2 scalars, you could find like 1 scalar per column for columns 1 and 2, that would describe column 3. And now in the case of this example, you can see that when you're converting distance from meters to kilometers, you just divide by 1000, which is why this distance of 150 meters corresponds to a distance of 0.15 kilometers. Bearing that in mind, take 2 minutes, talk to your partners, and figure out what the rank of this matrix is. If you want to ask, you can ask me, Manana, Sam, or your AIs for help. Okay, by show of hands, who thinks the rank of this matrix is 1? Who thinks the rank of this matrix is 2? Who thinks the rank is 3? Who thinks the rank is 4? Does anyone think the rank is 5? Okay, so the correct answer is 3. Someone who answered 3, would you like to explain how you figured out that the rank of the matrix is 3? Pranav, I saw you raise your hand for 3. You want to answer? Thanks, Pranav. That's perfectly correct. I'm just going to repeat it in case anyone didn't hear him. So, distance and time, you can't describe one of these in terms of the other. So, both of these columns, so this has at least rank 2 just based on these two columns. When you look at this distance column, you can see that you just get it by dividing this column by 1,000. So this doesn't increase the rank. This is linearly dependent. So the rank is still 2. Then we get to time, and similarly you just divide by 60. So this doesn't increase rank either. Now when you get to speed, you might think that this doesn't change the rank either because speed is just distance by time, and we have our distance and we have our time, right? But the way rank works is in terms of linear combinations. So there's no scalar you could multiply this column with and no scalar you could multiply this column with such that their sum would give you speed, right? You have to divide distance by time. That is not a linear operation. So this column needs to be there for you to describe speed. You can't just get it from a linear combination of these two columns. So that's why the rank of this matrix is 3. Similar question, what is the rank of this matrix? These 5 columns are the same, but now you have a speed column for kilometers by minutes. So now we have a 6th column here that is this column divided by this column. Take 2 minutes, try to figure out what the rank of this matrix is. And feel free to talk to your peers. You know, I'm changing that. Don't feel free, actually talk to your peers, guys. They're very valuable when it comes to learning how this stuff works. All right, in the interest of time, who thinks the rank is 1? Who thinks the rank is 2? Who thinks the rank is 3? Who thinks the rank is 4? Who thinks the rank is 5? Who thinks the rank is 6? So most of you voted 3, which is correct. You might think that the rank of this matrix is 4 because, like we said, you can't get speed from a linear combination of your distance and time, even if speed is distance by time. So you might think having this column means you need to divide this distance column by this time column. And if we didn't have our 5th column, that would be true, so your rank would have to go up. But since we already have this column, the speed in kilometers per minute is just a scalar multiple of speed in meters per second. Specifically, if you had a speed in meters per second and you wanted to get the speed in kilometers per minute, you would multiply by 60 because there's 60 seconds in a minute, and you divide by 1,000 because there's 1,000 meters in a kilometer. So the rank of this matrix is still 3. Back to theory. These are just the answers, so you can check them out in the slides. We'll post them later. Right, now going back to PCA. The underlying principle of PCA is that the components with the greatest variance are the ones you want to focus on because they generate the most variance in your data. So when you're trying to figure out which components from your data you want, you take the ones with the greatest variance in the hope that because they represent the greatest variance in components, they give you most of the variance in the population, and when you're analyzing population trends, variance is a good thing because it differentiates one data point from another. Now, if we're just looking for greatest variance, why not just take 2 columns with the greatest variance, right? Seems like it makes sense. The reason we don't do that in PCA is because there might be some underlying factor that correlates two columns which have great variance. So for example, let's say that if you have data for a bunch of students in the class and you see that the two columns with the greatest variance are height and shoe size, you might want to pick those two as principal components. But based on how proportionality works in the human anatomy, if you're really tall, the odds are you have big feet as well. So these two factors aren't independent of one another. They come from the same underlying distribution that generates a correlation. So you want variances that are unrelated to each other, because that means that one kind of variance has nothing to do with the other kind. So when you have both kinds of variances and you're including both of them, the variance it produces in the population is greater than the variance you would have gotten from two columns which were correlated. In more technical terms, we want orthogonal components as compared to columns that aren't orthogonal to one another, because in that case they'd come from an underlying distribution and their variance wouldn't be as significant in terms of contributing to the total population variance. Now, does that mean we just, well, the animation doesn't work properly, but in terms of PCA, that doesn't mean we just pick, let's say, two columns, we keep them and we get rid of the rest. The interesting thing about PCA is that it creates new components as linear combinations of components you already have. So if you had like height, weight, and age as your columns, in terms of principal components, you could have 0.2 times the height columns plus 0.8 the weight column plus 2 into the age column. So even though you're not using just the age column or just the weight column or just the height column, you create a component which has weightages from other columns. And so the first principal component would be some combination of these columns. The second principal component would also be a combination of the original columns in such a manner that these two columns are orthogonal to one another, which is why principal component analysis is so valuable. It gives you orthogonal components which capture as much of the variance as possible. Now the question obviously becomes, PCA is great, theory seems fine, how do we actually do it? So as Sam covered in lecture, this is the theory behind performing PCA. And I'd actually say don't focus too much on this, just look at it. Yeah, this got boring. The thing is, we don't actually need to worry about how to perform PCA in theory, because when it comes to implementing it in practice, what we do is different, but gives us the same results. Specifically, we perform singular value decomposition, or SVD. Again, as Sam covered in lecture, this is how SVD works. You have a matrix X which has already been centered, and then you decompose it into U, sigma, and V. And the descriptions of U, sigma, V are given here for your perusal. The last things you want to look at before you start answering questions for PCA is why we're doing what we do, right? If you want to understand why we're centering our data, I'd refer you to this link. If you want to understand what U and V are when we say left and right singular vectors, Stephanie covered that on Piazza. And when it comes to singular values, we don't want to be too linear algebra heavy in this class, but what I want you to know is that when you have singular values, the total variance in our data set is the sum of the square of all the singular values. Now the question becomes, how do we actually find principal components? As we already said, you can decompose your matrix X into U sigma V, U sigma Vt, and if you rearrange those terms, you get that the matrix product of X and V is the same as the matrix product of U and sigma. So the columns of either of these matrices are your principal components. It is equivalent to take the first column of XV and it is equivalent to take the first column of U sigma. They're both going to represent your first principal component. So that's a lot of the theory covered. Is there any question you guys have before we start looking at practice problems and problems from previous midterms? Yeah? Okay, so for in case anyone didn't hear, we're talking about street plots and how the first two components seem to have more of the variance. So street plots are organized in such a way that they're arranged in descending order. So one component will always have more variance than the component that comes after it. However, how much the variance differs depends on the data set. So in case the examples you've noticed have variance decreasing a lot after specifically the second principal component, that's a coincidence. You could have data sets where the variance barely decreases with each component, but it does decrease as a property of tree plots. And you could have one where after the second or third component, the variance is practically zero. But if you see a tree plot on the midterm, like look at the axes, like look at what the values of variance are. Don't just assume that, okay, variance is zero after the second component. In fact, I'd recommend checking out discussion 6 because there are two street plots placed side by side, and you can see when a street plot indicates PC is a good idea and when it indicates that a lot of components have lots of different variants, so you can't just use your first two. Make sense? Any other questions before we get to the practice problems? Seeing none, we'll move on. So this is a question from the midterm one from last semester. You also covered this in discussion. So we're going to go through this one pretty quickly. I would say take maybe 5 minutes, talk it over with your friends, ask us or your AIs for help, and then yeah, we'll discuss it as a class.
It's like super small.
Oh. Anyway.
So,
Oh, I mean, yeah, you handed this, I'll put it up right now. Sure. And mic's off. That's off.
yes.
About that one question on the phone.
Yes. I wasn't really sure what the question was. Like, the question was pretty close.
Okay.
So can you with this Google slideshow, the lecture slides that folder is public. If I can push it through.
Oh, I'm just gonna do that.
It's not that. It's not this folder.
Oh, yes.
It's just slides.
I think you can just finish or something.
Yeah, you can just kind of drag it.
Yeah.
Go for it.
Where
You could have.
Yeah. Click on this. Click on this.
okay.
You'll be able to put it into the folder. Click this button up here. The one above.
Oh, yeah.
And then organize it. Click organize.
Am I in the right place? It's just.
Scroll down.
I think that should be. No, it should be here. It
Yeah,
should go to share.
Where it's start. It's start.
Did you start it? only problem that you didn't want to push it is because you have to answer stuff to this, right?
Yeah.
It's okay, but like now we will go through it and then they will see slides.
Okay, let's start getting back. So in the interest of time, I'm just going to move to the answers directly instead of like a Q&A thing. So let's start off with 5a. As I clarified earlier, principal components are columns of either the product of x and v or the product of u and sigma. Either works, they're both fine. It's important to note that you want xv, not xvt. So in the first case, x into u transpose, that makes no sense, so you can just move on. Over here, we see the product of u and s, which is what we're looking for. So now we see if we're actually selecting a column from there. So this means we're just taking everything from the rows, and this means we're selecting the first column. So this selects the first column from the matrix product of u and sigma, which is what we want for the first principal component. So this is fine. The second one is, or the third option is quite tricky, because you might think that the dimensions of Vt are 1 by n, so there's no way it should even be able to matrix multiply. But Python has an inbuilt feature where if it sees that this is n by n, for example, and this is 1 by n, it knows to automatically transpose this and then carry out the matrix multiplication. And so if you take this is the first row of Vt, but if you transpose this, it's the first column of V. And when you multiply this with x, you do get your first principal component. And if this, so this is valid. If this seems a little confusing, that's perfectly all right. So I wrote this midterm, right? As in, I attempted this midterm, and we'd never been taught this. So like pretty much the entire class got it wrong. And we're very salty about that, but at least you guys now know this. And the last option, this one is pretty straightforward as well. You make sure that you first transpose your Vt. So now you got your V matrix back as it was. You multiply x by V, so which is one of the valid matrix multiplications. And now you just want to take the first column, which is what this does. So this is valid as well. In terms of proportion of the total variance, as I said earlier, the total variance in a data set in terms of singular values is the sum of the square values. So the total variance is going to be 3 square is 9 plus 1 square is 1 equals to 10. And if you want to see the variance of each individual component, then you just square the individual singular value. So the first principal component has singular value 3, which means the square of that is 9. So the proportion of variance accounted by just the principal component is 9 by 10, or 0.9. What is rank of x? Rank is defined as the number of positive singular values. So over here we have 2 positive singular values, and then we just have zeros. So the rank of this matrix is 2. Any questions? Yeah? Are we talking about the fourth option? Right. So David asked what happened in this option if we didn't have parentheses. So in this case, we'd be selecting the first column and then multiplying it by x. And because of how matrix multiplication works and because we just want the first principal component, that still work out fine. But it would be good practice to actually multiply your full matrices and then choose columns from there. So if you're ever writing code to do it, I'd recommend that you do the multiplication first and then choose your rows or columns. Moving on to this question. This is from last semester's final, but whatever content you need to answer this question, you already know. So take another 5 to 7 minutes and then we'll discuss the answers. Oh, also in case anyone has difficulty like at the back reading what's on screen, the slides are now up on the website, so you can access it from there if that's more convenient for you. All right, let's get back. I just uploaded the answers on the Google Slides because I didn't want you guys looking at it before then. But now let's go through them one by one. 6A, rank of the matrix with rows corresponding to the taxi trips. In this case, the rank of the matrix is 2 because even though the columns you're dealing with are, even though you have number of blocks, total distance, and fare, the rank is only 2 because since you know every block corresponds to like 0.1 miles, you can calculate distance just based on the number of blocks. You can just multiply it. So because of that, the rank of the matrix is 2. Rank of the 4-column matrix containing columns, and fare you can't describe using either of your 2 columns, so that's a separate one. So that's linearly independent, so the rank in that case, it brings it up to 2. Part B, rank of a 4-column matrix containing columns for 3 variables as well as a column of all ones. So in this case, the rank is still true. It's still 2, I'm sorry. So you might wonder what column of all ones is doing. So in this specific case, it means that you can now express fare as the distance plus like 3 into the column of ones. So because the formula for fare is 2 per mile and $2 per mile and $3 per trip, you can just get the first part, like the $2 per mile, by multiplying the distance column or the number of blocks column, either works, and you can just get the $3 per trip by multiplying the ones column with 3's and then adding it to what you already have. And it's going to make more sense why we add ones to a data matrix when we get to the statistical inference part. But in the context of rank, because we're adding a new column, but because we have this new column, we can now express fare as a linear combination of columns we already have. So the rank is still 2. Moving on to the true and false, the first one, sum of the singular values will be total variance of data set. That is false. As we covered, it's the sum of the square of the singular values. So make sure you don't make like silly mistakes like that in the midterm when you know the right answer. Second one, singular values will be greater than 0. No, not necessarily. This is false. If you saw, as if we saw in the example from the previous question, you can have singular values that are 0, and you can also have negative singular values. So unless you've explicitly been told or been given a set of singular values that are all positive, this is not true. Option 3, the dot product of the first and second columns of V will be equal to 1. That is incorrect. The columns of V are orthonormal to one another, or are orthonormal, which means they're orthogonal to one another, which means that if you have 2 columns of V and you take that dot product, you'll get 0. Because they're orthonormal, the magnitude of each column is 1, but that's not what's being asked here. We're talking about the dot product of 2 different columns. And last one, a scatter plot of the first 2 columns of U sigma will form a straight line. This one is true. And yes, the answers should have been added. Oh, it hasn't updated on this. So so this is my section wrapped up. Just a few pieces of advice I want to leave you guys with. Make sure you read the question properly in case there's something that isn't clear. It might make more sense if you read it enough times, and there might be a vital bit of information that isn't that clear. So make sure you read the question at least once or twice completely before trying to attempt it. In terms of time, make sure that you actually have time to attempt all the questions, because it would really suck if you got stuck on a question where you weren't sure, and there are questions where you definitely would have knocked out of the park, but you just never got time for them. So look at how many marks a question is worth and make sure you pace yourself accordingly. So this is an opinion that is specifically mine. It does not represent the stance of the core staff. Previous midterms have had like coding questions where you have like, Python and SQL code that you have to write out. What I've personally done when I've taken data 100 midterms and finals is do that at the end, because I've personally found that to be the most time consuming part of the midterm. So I want to make sure that I get time to do everything and then come back to that. I would recommend that you try this out on a practice midterm or 2 yourself and see if the strategy works for you. But that's what I've done and I haven't regretted it. And yeah, make sure you've eaten and gotten sleep. Beyond that, that's my section. Thank you so much. Best of luck. And I'll hand it off to Manana.
Hi everyone. Hi everyone. Can you hear this way? No? Is this better? Okay. So we're going to take a little break, like 3 to 4 minutes, and we will fill in this attendance form. Yeah.
blocks here, so I'll take those blocks and like
Put it like back?
on my pants pocket and like put.
No, I think it's fine if this stays here. I'll just put it here so I do not have to hold it. I have a question. Are transport printed today?
Yeah.
Do they have access to the answers to what the review you have prepared?
No. I didn't put the answers anywhere because I knew I'm going to do them. Yeah. Just try to like put them like more there. Yeah. Because I wanted to like make a form, like logistics for our staff, and then make sure where they will take the midterm, who will take the midterm, like stuff like that. So where will it be the midterm when it's graded, or will it be your office?
It'll just be my office. I'll keep the door locked. So in the morning I'll come by tomorrow, and like we can go over the things during the afternoon today. Just make sure we have everything there.
Sounds good. Yeah. Yeah. Don't worry.
So I'm a little confused about what's in each of these dimensional components and
Yeah.
there.
So when you essentially when you decompose x to single values, your purpose is to get orthogonally dependent like vectors, principal components.
And isn't that in like
Okay, I'm gonna. So when this middle one is the easiest one because it's a diagonal matrix and it has all the singular values.
so it's like a scale on it.
It's yeah. And then you have u and then u transpose. So what is in u we call left orthonormal vectors, and then what is in v we call right orthonormal vectors. And the way it is that u equals u is the eigenvector, like eigenvector. Yeah, u is the eigenvector. This is for x and x transpose, and then vt this is the eigenvector space x transpose x. And
Sorry, what?
so
U is the eigenvector basis
for x times x xt, and the eigenvector basis of x transpose x, and it's only x as yeah. And that's much about it, but the idea is that u and v consists of orthonormal vectors. So all the vectors there are orthonormal. So when you split them with sigmas, you get the principal components, which are linear combinations of like singular values and these orthonormal vectors. You get principal components, which are orthogonal, so which are necessary.
principal component is like after you multiply these two matrices together.
Yeah.
The principal component is like the
Column. Yeah, it's the same as like when you multiply these, the principal components are the columns for that.
Thank you.
Okay. Is this good? Yeah? Okay. Let's continue our review session. And we're going to jump to regex because this is the second highest demand review topic. Somehow regular expressions seem very confusing to everyone because they just seem like a bunch of characters that just do not make sense. They are a bunch of characters, but they do make sense. And the way we will break it down today is that we'll say we'll have regular expressions which contain ordinary and special characters. And ordinary characters are the ones that they just match themselves. So if you were to write a pattern which says just dog, it will just match dog and nothing else. Okay, and my examples are flower, which will match flower, and KitKat which will match KitKat, and then there is like exclamation mark which will just match exclamation mark, so on, so on. And there are special characters or meta characters, which have like some magic power, and they match something other than their meaning. And here are some examples: plus, which matches preceding character one or more times, or like the $, which signals that you want to match something at the end of the line, or like question mark, or there are brackets, braces, I don't know, so many of them that is like, it's literally very scary. But wait a minute, you're given everything in your cheat sheet. Like not cheat sheet, your reference sheet. So don't spend time on memorizing these meta characters. Just try to understand how they work and what is the logical way of reading these regular expressions. Before we start reading some regular expressions, here is like a important line. If you want to get rid of the magic power and just match the ordinary character of your special character, you use backslash. So whenever you say backslash and plus in your regular expression, it should tell you that you just match plus and not the preceding character one or more times. Okay. Now let's read some of the regular expressions I have for you. Let's start from this one, which has only 4 characters, but all of them are special, like meta characters. So you see this, you have the caret, and then you have like 1 dot, and then you have star and $. And this seems a complete mess. But what it says is, okay, I have caret, which indicates that I'm going to match something from the beginning of the line, and then I have the $, which indicates that I'm going to match something at the end of the line. This is already useful information. And then when you look inside, you see this dot, which technically matches everything in regex. And then you have the star, which is a greedy meta character, and it tells you, okay, I'm going to match whatever I have preceding, like this dot, 0 or more times. And if you want to know where is the answer of all these 4 characters, you come back to your reference sheet, and then you just carefully examine. And you see here, you have the caret, you have the $, and then you have the dot, which matches anything except the new line. And then you have the star, which matches the preceding character or group 0 or more times. These technically will match the whole line. Okay, is there a question about this one? Feel free to ask questions whenever you need, and not only me, but also our 2 academic interns are here to help. So please utilize the help. Okay, let's read the second expression. Once you know how to read the expressions, regex expressions, it will be very easy to construct your own. So what we have here, again, you have the $, which will tell you what? Just give me. Is the end line. Yeah, you're matching something at the end of the line. And then you see this parentheses. Okay. Important thing, in regex, wherever you have parentheses, it indicates that you're matching a group. So whenever you want to find a group, so you want to find like groups of, we'll do on our example. You want to find group of like male, just the word, or female, you use the parentheses. And these, I don't know how to call it. What's the name of that? So basically this one matches the expression on either side of expression. So whenever you see it, it should signal you that you have 2 sub-expressions in your regex. You have right and left hand sides of your regex expression. And then you see this dot, which is familiar to you. It matches everything except new line. But then, wait a minute, it has this backslash before that. So it means now it doesn't have its magic power. It just matches the dot. So if you were to give me an example, what will this regex expression match? What will it be? This is a question. Do you have any idea what will it match? Yeah, I see like right reactions. So it is male or female at the end of the line, which has this dot after it. Okay. Questions about this one? Yes. Amazing question. So she asked, what will happen if we change the parentheses and put square brackets? When you change the parentheses and you have square brackets, now you do not look for groups. So you do not look for male or female separately. But now you have brackets where you treat all the characters equally. And in the brackets, your matching group used to match any of the specified characters or range. So A, B, C, D, E, for example, that is given here, is going to match any of the characters, treating them equally and separately. So here it will be it will ask you to match either M or A or L or E or F, E, M, L, L, and E. So it will just treat them as letters, not as male or female, but just letters. Yes?
So the OR operator there will be just redundant.
Yeah, the OR operator will be just redundant there. Okay, good question. Okay, and the last expression, let's read this one. This is my favorite. You'll see why. So it says, it starts with a caret, which indicates the beginning of the line, and then it has uppercase M, and it matches uppercase M 0 or more times. And then we see, again, greedy matching. I mean, we might think that it's going to do greedy matching because we have dot and then star. But wait a minute, we have star and then question mark. And then if we go back to question mark matches the characters 0 or 1 times. So it's not greedy matching anymore. It's going to match as few times as possible. And then where we have NA in a parenthesis, which means we're looking for a group, and these curly brackets indicate quantity, how many times you want to have that group in your match. So here I'm saying, okay, give me some word or pattern that will start with M, will match some things, some characters, up to 2 groups of NA. And it's my favorite one because it technically matches my name, which is Monana. It will have M, and then will match A, and then it will go like 2 NAs. Yes?
So does the question mark apply to dot or to
Okay, good. So question mark applies preceding characters. So it will apply to whatever comes after M and what precedes the groups of NA.
so like the question mark and the star?
Okay, the question mark and star together say that. So okay, the dot and the star together will say I'm going to look for characters 0 or more times. So and then question mark will say whatever I have before that, so the character 0 or more times, I will look for that 0 or 1 times, which is just like confusing way of writing that I want to match whatever is in between M and then groups of NAs. 0 or more times. Yes? Unless you have only one letter, which is the beginning of the end of your line, it's redundant. Because if you have just like A, and that's it, and that's the beginning of the line, and that's the end of the line, then I think you're fine.
So like when you're using star and sign group, is it around the flash?
Which one?
Like in terms of shape one using plus sign or sign, you put it around the flash inside.
Okay, whenever, if you're using plus or star to look for groups 1 or more times or 0 more times, you use it after the parentheses. If you're looking for like one character 0 or more times or one or more times, you put it after that character. Okay, are there any other questions? Yes? What? Okay, so what will happen is that whenever, if you have like long sentence where you have like M and bunch of characters and maybe like NAs as well, and then you have NAs at the end of the line, what question mark will do, it will try to match as little as possible. So whenever it finds the first NA, it will stop. So it will not just go like till the end of like the very last NA, it will stop like when it meets the first NA. Any other question? It should make more sense now. It looks like a bunch of characters, but it has meaning. Okay. If this makes sense, now your time to shine. We have a question for you. Take like 3 minutes. I promise it's not very, very complicated, so 3 minutes will be enough, and we'll be around to help ask questions. Okay, I feel that the discussion calmed down a little bit. Then let's come back and see what is our consensus. What is the answer? So do you think is the option 1? Raise your hands if you think it's BAK. Raise your hands if you think it's the 3rd one. Raise your hands if you think it's the 4th one. Raise your hands if you think it's the 5th one. Raise your hands if you think it's the 6th one. Okay. I think I did not tell you something about find all. And in general, you're right. If we were just to match this regular expression, what it tells you is that, okay, we start with the dot because you have backslash and dot, and then match everything. So you will start here and you would match everything, right? And that's what I saw, and I'm very happy that I saw that. It means you were following me. But there's a catch. We're working with find all, and find all matches all the sub-matches that you have there. So instead of like selecting all, it comes and selects emp3, like dot emp3, and then selects dot BAK, and puts them in the list. Because red.findAll returns list of all the matches you had. And then you have this one. Is this confusing? Do you have any question? Yes? What?
There was a question about matches, that only match the one person. Is that,
Wait, I didn't.
sorry, it's kind of hard to explain just without the problem, but I think
Yeah. The first one? This one? This one? Okay, then I'm missing something, and I'm sorry about that. But maybe I'll check this, and maybe I'll post the clarification. But if you did this one and you'd all raised your hands for this one and this one is correct, then you all did amazing job, and I was gonna fail the midterm, not you. So you're doing amazing. And this would match in general, like if that was a pattern, but I thought the find all works a little differently. But it's okay, I'll clarify this later. Okay, I have more examples of find all. Take like 3 minutes to work on this one. Okay, let's do the same thing with this. Who thinks that the first option is right? What about the second one? What about the third one? Fourth one? Fifth one? And the last one. Okay, this time I saw the majority of the hands, and it's very good. We got this one right, and I agree with you too. So what this regular expression does, it says, I have cat and dog in the brackets, which treats them all equally and separately looks for either of them in your word. And then you see you have O, that will be the first match, and then B is not in your bracket, and then C is in your bracket, and then A is in the bracket, and then T is in the bracket. And then the find all will match all of them. We'll find all of them and put them in the list. Any questions about this one? Yeah. Yeah. Okay. Okay, the other example, take 3 minutes for this one. Okay, let's do this together. This one looks very, very confusing, and it is kind of confusing, but let's actually read the regex expression before finding the answer. Whenever you see this straight line, which is the operator for OR, it kind of divides your regex expression to two sub-expressions. So it will be easier for you if you treat this regex as like collection of two sub-expressions. And now let's think about the first one. The first one starts with the opening bracket. It has slash, and then it wants to match everything which is not a closing bracket greedily, and then when it sees the closing bracket, it's done. It finds a match. That's the first sub-expression. The second sub-expression says you should have like opening bracket, and then you should match everything which is not a slash greedily, so 0 or more times. And then when you see the slash and the closing bracket, you stop. That's the second sub-expression. And then you either match the first one or the second one. You look for either of them. And now let's look at the string we have. We have the opening bracket, body, and then closing bracket. Will this be a match? This won't be a match because it doesn't have slash, either in the beginning or at the end before the closing bracket. Okay, let's look at the second part, h1 in the brackets. Will this be a match? No, this will not be a match because it doesn't have, again, the slash either in the beginning after the opening bracket or before the closing bracket. What about the text? No, it doesn't, it's not even in the opening and closing brackets. What about slash h1 in opening and closing brackets? Yes. Okay, that's like one thing. And then what about the image with slash and then closing bracket? Yes. And then body with slash and closing bracket? Yes. Okay, then let's look for the answer. So it's not this one, not this one, not this one. Here, we found the answer. It's this one, I think. Right? Do we agree? Okay. Wait. Before I go on, like move on. Yes, question? What? Oh, we escaped the backslash. Backslash tells us to escape. What? Really? Wait. So here, backslash escapes the meta characters, and then forward slash doesn't. Oh, is there a forward slash? A backslash before the forward slash? I don't think we have that here. It's not in the pattern. Is it in the pattern? I don't see it. Okay. Okay, let's move on. So now that we kind of figured out what is regex, we should know how to use regex for our own purposes. So we should know how to utilize regex for EDA, for data cleaning purposes. And the way we do it is we usually like to apply in the string methods and find matches or replace the matches or even like extract some groups. So I'm not going to read the whole documentation of all these methods, but I linked it in the slides. So be a good student, go and like see what you can do with this .str and the method name, and then how you can use your regex there. But some things that you have done in your homework 3 is that you had series and then you did .str, .lower, and you made it into lowercase. And then if you want to replace some pattern with some other string, you can find the patterns and do dot replace and then replace with the REPL. And then you can count or extract groups or find all of the patterns. And these are some things that you can just generally do. Okay, after this point, the slides are kind of collection of facts or like some revisions from slides. So they're not like very comprehensive about like one specific topic. So right now we're going to do some like EDA and data cleaning in Pandas. And the first thing that should come to your mind is how to deal with missing values. And the best answer is that if you can replace your missing values, just replace them. If you know how to find the values for them and put them in your data frame, just do it. Don't get rid of your values. But other method that you've dealt with in your homework 3 is that remember whenever you didn't know what was the sentiment value for the word in your expression, you just fill it with 0. That's another way of dealing with missing values. Some people just like to fill in averages for missing values or medians, and some other people just get rid of the missing values, like the records of missing values, if they do not know what to do with them and if they have sufficient data. That's little talk about missing values. And then sometimes you can correct your missing values when you do joins, because you might not have the value for that one in this table, like particular table, but you can have it in second data frame. So you might want to join. And joins are like very useful for other purposes too. Whenever you have like information in one data frame that you do not have in your previous data frame, and you want to aggregate them and get like a new data frame, you can just do joins. And the general idea of joins, the ways you can do it is you can do inner joins, which take only the common records and add new values for only the common records from both data frames. You can do left joins, which take the records from left data frame and add values to that data frame. Or you can do right join, which is the exactly opposite of the left join. You take the records of right data frame and add records to that data frame. And you can do outer join, where you decide to keep all of the records and kind of to just merge the data frames together. And then the way this syntax looks like is like pd.merge, and then you have the left table, right table. You're telling the merge how to do the merge, how to do the join. And then on left on, you're passing the argument of the name of the column. And on right on, you're passing the argument of the right column. The way you've seen it in your homework is also you take the left table, or like the data frame, you do that merge, and then you do the right table. And then everything after that is just same as in the documentation. Okay, this should be like, yeah, okay. Now we talked about joins. Time to practice it. Take 3 minutes for this one. Okay, let's tackle this one together. Actually, before we do that, let's check what do you think. Well, who thinks it's 0? 1, 2, 3? Okay, great. I don't remember the answer by heart, so we're going to do it anyways. So we're going to first merge animals with visits on 8. And pay attention that animals is your left table and then visits is your right table. And whenever it's not specified how you're merging them, how you're joining them, the default is inner. So you're going to do inner join. Okay, so you're going to take the 8 from animals, which is here, and try to inner join with 8 with visits. One thing that you first need to notice is that 8 from animals has 3, while the 8 from visits doesn't have that. So with inner join, you will end up having only 0s, 1s, 2s on your 8 column. Okay, and then you know that you're going to group by whatever you have after the join by color, and then select the age, which is this column, and then you're going to take the mean of the age. So let's do this. So whenever you join with 8, you're going to have 0, 1, 2, and 3 2s, right? On your 8 column, because that's the mutual values. And then now you're coming here, and your 8 is going to get white, golden, golden, so it's going to have that colors. So essentially, you're going to have white and golden as groups, right? Do we agree on this? Okay. So after you do that, and you select the age, so you select here, you're going to select the age which corresponds to 2, 5, and 1. And then you're going to take the mean of this. And the way you're going to do it, because you will have 2, you have only 1, 0, you're going to have 2 there. And you're going to have a 5 for 1, and then you're going to have 3 1s for the, wait, I confused. Okay, wait, when you do group by color, you have white, golden, and then you're going to have, when you select age, you're going to have 2, 5, and 1s, and it's going to repeat 2, 5, and 1s according to the 8 you have for them. And because you have 1, 1, and then you have 1, 0, and you have 3 2s, you're going to have 1, 2, and then you're going to have 1, 5, and then you're going to have 3 1s. And you're going to, the sum of this is going to be 2 plus 5, which is 7, and plus 3, which is 10. And then you're going to have 5 values of that, and then 10 over 5 is going to give you 2 as average. So yeah, I just confused a little bit, but that's how it goes. Are there any questions about this one? Yes? What? Oh, yeah. Yeah, when we group by, we have 2 white and gold, and then like this too. Yeah. Okay, wait, I want to clarify this one. I confused it a little bit. So when we do animals merge on visits on 8, we get the inner join of 0, 1, and 2 as 8. And then when we do group by color, because we have 2 colors, white and golden, and when we take age, we're going to have like 2 columns, and then we do mean of that. So we're going to have, for each color, we're going to have the mean of the age. So we're going to have 2 elements in your list, in your series, and then when you take the length of that series, you're going to have 2. So you don't need to calculate average or anything. You're just concerned with the elements in the list. Please ask me questions about this one. No questions? Okay. It's 11, and there were like more questions. I will recommend to go through them because I picked the questions and to exercise them. All of the exercise problems are from past midterms, so you can access the answers for them. And before you leave, I was like thinking while I was doing the presentation about this one, and so because it's doing grid matching, that was my bad. It's going to select this one. It's going to take from dot, and it will match everything till the end of the line. So it will be one match. Is this clear? Yeah. Sorry about that one. Okay. Good luck. Yeah.
Questions on this exam. So there's one really similar to the one that you mentioned before. It's like select two elements from this square brackets, and I'm not sure why. So somebody explained for me, and I already know that this one it's not a special meaning. It's just like a symbol, right?
Yeah.
So all kind of combinations is fine. So for these questions, if I want to find all the matches here, I'm not sure why the answer is these specific elements. Because why not OW or like let's see. Yeah,
I think the way it does, it's like starts from looking for this chain from the beginning, and it goes off. And then it goes on the V end, and then A end.
So
like
you
it
will
matches.
not overlap,
No.
just like
Yeah, it's like the
okay. Thank you.
Hey, when you were explaining that last one for the group buy, I wasn't sure if you misspoke or not, but you said that the columns turn into, so the color labels become columns, but they become rows.
Oh, yeah, I meant like for each color, you're going to have like a one row.
Yeah.
Did I say column? Okay, I'm sorry.
It's all
about
good.
that.
No, I was just
Yeah.
making sure. Okay,
Yeah.
cool. Thanks.
So what that actually is so basically, if you're going to